Hi there, this is Ellery Galvin with LISA, the Laboratory for Interdisciplinary Statistical Analysis at CU Boulder, and this is our collection of videos about programming in R. This video is going to be about using functions written by others. Let's get started. Functions are fundamentally a way to use code written by someone else and also a way to make code easier to read and write. When we use a function, we say functions are called or executed or run. All these things are the same. They just mean using the function. Functions will have what we call arguments. Arguments are just inputs to the function, bits of information the function needs to do its job. The syntax for calling a function starts with the name of the function. Then we put parentheses. The parentheses indicate that we are calling the function. And in between the parentheses, we put the arguments. I'll put argument 1. And if there's more than one argument, I put a comma and then argument 2. The spacing in between the parentheses doesn't matter from R's perspective, but I find it easiest to understand if you write it like this. There are many functions in base R. You have plenty of time to learn them all, but we'll investigate a couple today. For example, there's the print function. You'll see R knows that print is a defined object in the namespace. If I write print without the parentheses, I'm just referring to the function called print. And indeed, if I hit enter, R says that's a function. But if I define a variable such as an integer, and then I call print of an integer, indeed, it prints the value assigned to the variable an integer. Notice I used the name of the function, print, a parenthesis to indicate I'm calling the print function. The argument was an integer, and this closing parenthesis indicates end of arguments. The print function can be especially useful if there are long and complicated vectors or strings of letters that I'd like to check. Now, usually, when we use a function for the first time, we're not actually sure how to use it. I'd like to show you the sample function. In order to use the sample, to check the documentation for the sample function, I call another function called the help function. I write help, parenthesis, sample, which is the name of a function I wish to see the documentation for, and a closing parenthesis. You'll see over in the bottom right, the documentation comes up. Let's go over each of the sections of this documentation. The description section is just plain English. What does the function do? Sample takes a sample of the specified size from the elements of X using either with or without replacement. Let's get some more detail. The usage section shows us what's called the call signature for the function. It's showing us what we need to do to use it. We see the name of the function, the parenthesis used for calling, and then these are all the names of the arguments, and those that have an equals sign are showing us the default value of that argument if I don't specify it. So here, if I don't say whether to sample with or without replacement, it assumes that I don't want replacement. R has a special understanding of true and false that we'll talk about in another video. But for right now, it essentially has the meaning that you might otherwise assign to it. False means do not replace. Now we have the arguments section. The arguments describe the meanings of the inputs in detail. So the argument referred to here as x is either a vector or one or more elements from which to choose, or a positive integer. Notice that it's telling us both what kind of object x has to be, as well as the meaning, elements from which to choose, of that object. Now, this documentation is combined with another function called sampleInt, which has some different arguments. N belongs to the sampleInt function, so we'll skip it. Then we have size. Size is a non-negative integer giving the number of items to choose. And replace, should sampling be done with replacement. The details section contains other information that the author of the function thinks might be helpful when using the function. It can take on a lot of different use cases depending on the function. I usually only read it if I'm looking for something in particular. Then we have the value section. The value section tells you the output. Here it says, for sample, the output is a vector of length size with elements drawn from either x or from the integers 1 to x. Then we have references. The references section shows you how to cite this function if you were to use it in a say an academic context. It can also sometimes be references for, say, who developed an algorithm that was implemented by the function. The See Also section contains other functions that might be useful in conjunction with the function you're looking up. It can also sometimes contain related functions that have similar functionality that you might also be interested in. And finally, the examples section shows you, well, examples. Notice I can hit this link, Run Examples, and it will take each one of these examples and actually show me the output when that code is run. I can press the back arrow up here to go back to the documentation. Now, sometimes, even after we've read all the documentation, we're still not completely sure what that function really does. For that situation, I like to recommend the just do it attitude. Whenever you have a question or you're not sure how the function will behave in some special case, just try it. So let's try some things. If I create a variable called dat, and maybe I'll assign it to the vector 1, 4, 5, 0. Then if I call sample of dat, interesting, I got back the same thing. Let's call it again. Now I've got the same 4 numbers, but in a different order. And again and again. Now, you can call the function with arguments that are unnamed, but I can also say sample with the function called x equal to dat. And that has the same effect. I can also say sample x size equal to 3, and I will get, whoops, I forgot to type x equals dat. And I'll get 0, 4, 5, only 3 of my 4 numbers. Notice that I haven't seen any repeats. I never see the same number twice in the output. That's because we're sampling without replacement. Recall that the default value of the replace argument is false. But if I were to change that and I said make replace equal to true, and maybe I'll take a much bigger sample size, now I get repeats. All right, let's take a look at an exercise. Go check out the documentation for the seek function and the sum function. Write code that finds the sum of the first 532 odd numbers. If you're not sure what the arguments mean, don't be afraid to just experiment and see what happens. You can pause the video now, and I'll give you a chance to try out the exercise. All right, welcome back. Let's check out the documentation for seek. Seek says, generate regular sequences. Seek is a standard generic with a default method. Wow, this is not very informative. Let's take a look at the arguments, though. I can go seek from 1 to 1 by some function of the other arguments, something called length out and something called along with. Let's read what the arguments mean. From and to means the starting and maximal end values of the sequence of length 1 unless just from is supplied as an unnamed argument. Let's see if I can just figure out how to use the from and to arguments. If I call seek and type from equals 1 and say 2 equals 3, I see. It gives me the numbers, the integers from 1 to 3. That makes some sense. Then we have the by argument, which is the increment of the sequence. Let's suppose I say from equals 1, 2 equals 10, and I'll say now by equals 4. Now I can see that the distance between consecutive numbers in the sequence is 4. That's what's meant by increment. And then length out is the desired length of the sequence, a non-negative number. I can see immediately that these arguments can potentially conflict with each other. For instance, if I say I want to go from 1 to 10, but by is 10 or 9 and length out is 20, I can't possibly get 20 digits out because the only increment between 1 and 10 would be just one number. Let me show you what I mean. If I say seek from equals 1 to equals 10 and length out equals 11, ooh, I've learned something new. Now I can see that it doesn't just have to be integers. It will actually split the numbers from 1 to 10 evenly on that range. But if I add the by argument and I restrict us to counting by 2s, now I'm getting an error. It says too many arguments because the arguments conflict with each other. Okay, I have a sense of what seek does. Let's look up sum. Whoops. Sum returns the sum of all the values present in its arguments. Well, that seems simple enough. If I say sum of dat, I get 10. Remember, dat was 1450, so it added 1 plus 4 plus 5. The question asks us to find the sum of the first 532 odd numbers. So it seems that the first thing I need to do is get a vector containing the first 532 odd numbers. Well, we learned from the seek function that if I say seek from, I want to start with 1 because 1 is the first odd number. I don't need 2 because, well, I could figure it out, but I'm not really sure where the first 532 odd numbers end. But I can say I want to count by 2s because I want to go 1, 3, 5, 7, and so forth. And I want to keep doing that 532 times. That looks like it worked. Now all we have to do is take the sum of that sequence. And that's our answer. All right. We've seen that functions are a way to use code written by someone else and a way to make your code easier to read and write. In future videos, we'll see how to write your own functions. Thanks for joining me.